So started working quite a while ago, and didn't write unit tests for almost 10 years. I have no idea how I survived or got paid, but yeah, those were the days. In 2001, due to various interesting things in my life, I decided to become a tester. That was very interesting. Mostly I focused on exploratory testing. And on my way here, I realized that maybe this talk is about exploratory testing in a way. In fact, I ran a spell check on my slides, but I missed something. And my new friend here found a spelling mistake in my email. Like, well, how embarrassing. So yeah.
Oh, no.
But I dabble in tools. I like building tools, and I spent a couple of years at Google as a consultant. I helped them with their CI server infrastructure, and these days I work at GE. I've been there for about 7 months. I managed one of the building teams. We have several now.
You should stick to companies that are good with G, or?
Yes.
You left out one between Google and GE.
Oh, that's right. Vydra. Yeah, it was a fun feature. But actually, it's glad. So Mike and I used to work with the same company called Vydra. So that's a great point. And I should step back. The way I like to do these kinds of talks is to really engage with you in a conversation. Right? I have some slides to keep us going, but really this is all about you, especially thanks to all of you who drove a long distance to come here. This topic is rather controversial these days for various reasons. I'm hoping for a good conversation, and let's see what we can do. So GuideWire. So Mike and I worked at GuideWire, and the one thing. So I was an exploratory tester of GuideWire, and the one thing that was really amazing there is that developers did a really good job at this functional testing thing. So as an exploratory tester, it was actually fun and challenging, right? Like it was not easy to find useful or interesting bugs because the software was pretty solid. So in many ways, I think this talk is I'm going to fix this slide, Mike. You're correct. So again, mostly I work these days with continuous delivery, and these are languages I typically use. I really like Scala, although I'm going to be transitioning to Go because that's the hot new language. But my current shop is mostly Java. I don't have to write too much Java, thank God. Wow. Hey.
Okay.
Chapter 7, I'm opinionated. Let's
Okay.
bring it on. Yeah, Java 8 is getting better. I will give you that. But after doing Scala for a few years, I'm just not a person. But I understand why people still use Java. There's pragmatic reasons. Okay, so I want to hear a little bit about you, so I can sort of target my talk. Maybe let's go have a quick round of introductions, and let me know if you're a developer, tester, manager, both. So,
I manage a UI development team and do some bug fixing in my spare time, and do some stuff with Go, proxy, back into React-based JavaScript UI.
My name is Michael. I'm both a developer and a tester. I write a performance test framework, so when I'm writing the framework, I'm the developer, and when I'm using it, I'm the tester. And I write in Java because somebody had to pick up the slack after
I'm a C++ developer, and I do write unit tests from time to time.
all right.
But my code works first, so I usually have to do it too often, but yes. Okay. But I don't use CPP units, I actually just write my own. It's just easier and quicker to use it. But it is the style of CPP units.
Great. Okay.
I guess I consider myself an OODA loop tightener at the moment.
What?
An OODA loop. Observe, orient, decide, act. So
I
I
never
try
heard
to,
it, ooh, new word.
I try to, improve the development process and the lives of engineers so that they can get their stuff done faster. And a lot of that involves, you know, getting information in front of them in a quicker way and stuff like that so they can make decisions and act. In the past, I've done software development, and testing, release engineering, you know, all of that.
Hi, I'm Preeti. I'm working as a QA analyst at the State Farm Insurance. I'm mainly working on the UI side of testing for the different applications on the State Farm, for the policies and all.
I'm Sam, and I'm just into agile project management. I'm pretty interested in this topic, how it becomes competent. The topic is interesting to know about how functional testing is.
All right, let's see.
My name is Mike. I'm a marketing specialist and am not in QA or development, but I have to understand how it works to be able to market it, so.
I'm a program manager in a company that's I'm hoping to help turn the corner to Agile and Scrum, and I'm looking for any insights, especially in the integration of QA into that operation that I can get. That'll help.
I'm sure you'll get some opinion.
Keep my name.
Opinionated opinions. Right.
My name is, oh, you
Go ahead.
No, but you are in my.
I'm Rick, and I work at QASource and work with our clients, developers. I work with developers and QA engineers, and broad spectrum of software development as far as how we integrate with our clients and how we do QA and work with our offshore teams and making sure that we're adding value. And so here to learn everything I can.
My turn?
Okay.
My name is Igia. Moved from Pennsylvania. And for my life over there, I worked on a lot of industrial vehicles, including Siemens, GSK, JP Morgan, so, I mean, a lot of other verticals. IBM has always been as a QA, tester, analyst, UAT manager, and so the best part of the QA cycle, SDLC cycle I've enjoyed is being a UAT. I love UAT, I prefer it. And I'm in the Android development, so I'm starting to learn, and I've started my own 2 startups. One would be on the website thing, and would be on the website, and another is on mobile. So that's what I'm doing.
Jason. I mostly do Perl, Python, Amazon database stuff for analytics company. I'll be transitioning to a different group as a DevOps person where testing is hard to find. So far, for this group, DevOps has meant basically systems engineering, but we want to do Bamboo, continuous integration. That's
Great. All right. Well, so we have a great mix. This should be fun. All right, so let's get started. So the first thing I want to talk about is continuous delivery, because this is a concept that I think drives what I'm about to talk about. What is continuous delivery? Who wants to throw me a definition?
So it's just like an agile thing. It's an agile environment. And how I would put it is that different releases for different features, we keep on going. I mean, it keeps on iterating, the iterating cycle, you can see.
Okay, yeah, so I think that's pretty close. Typically, what I want to stress is that continuous delivery is about delivering value, right? And there are two constituents. We're delivering value to our customers, obviously, but also we're delivering value to our team, because our team is important to us, and it's, you know, it's expensive to build software, so if the team is not productive enough, things are not gonna go well either. So both kind of the upside, the top line and the top. And continuous delivery is built around the idea of a pipeline. So when you, well, really begins with user stories. But here I'm focusing more on the actual what developers do. But typically you begin with user story, and then you drive it all the way through to completion. And companies that do it well, they can often take a user story and put it into production, sometimes in a matter of hours, maybe in a day or two. So it's, they have an advantage over companies that ship very frequently, because they can get stuff to market earlier, they can get user validation, whether this is even a good thing to build. They can build software in very small pieces. So continuous delivery is something that is really becoming accepted as the way to build more software.
Can I ask you?
Yeah.
Why not?
Absolutely, yeah. I kind of want this to be very interactive here. This is the slides are just to help us along. This is a conversation for sure.
I know in the IT industry, everyone has their own, terms, but they all end up in the same. Oh, okay, I know you are talking about this thing.
Right.
Are you talking about the user story being like a requirement analysis or
Yeah.
something like that?
Yeah. So
The
typically
part
in
of the
Agile.
Scrum or something?
Yeah. So typically in Agile, places that practice continuous delivery, they have some form of Agile, whether it's Scrum or Kanban or whatever the new thing. And so typically, most places I've been at, they use the idea of a user story, which is something I think that is a little bit different from a use case. That in the old days we had use cases that are a little bit more formal. User stories are a little less formal, and they're usually typically a little bit smaller. And the idea is you can quickly move them through the pipeline.
It's like a combined,
It's definitely a requirement. It's definitely a requirement. And, some places use just cards they put on the wall.
Yeah.
Some places do cards and they use tools like Rally or Jira or version 1. Some just do it, again, in software. It depends how people want to track it. But so I want to focus a little bit on pipelines. Typically, you compile your code and you do some static analysis and you run some unit tests. And then maybe you have something you call integration tests, and I kind of put in quotes. Maybe you do, maybe you don't. The next part is very important. Package and deploy. Have you automated it? Do you have the tooling to get your stuff into a production-like environment very quickly and very efficiently? So we're going to talk about that a lot here today. And then functional or some kind of end-to-end test to verify that yes, in fact, your stuff even remotely works. And then typically you have your exploratory testing. So this kind of answers a little bit to your question, like what do QA do? In a lot of these environments, QA do exploratory testing. That's the main thing that they do. They may be able to help with automation, et cetera, but that's
You have design to test, it's in here somewhere?
yeah, so again, that's a great question, because I'm mostly focusing on technical issues. Typically, in the beginning, there's a phase of requirements deliberations or behavior-driven, and this is where testers and developers and product owners will collaborate on, figuring out what it is that we want to test, right? Building the right thing. So I have a few slides on that. So that's typically.
Great.
So the big question, hopefully, and I appreciate all of you coming here. Why like a compiler? Why did I choose this topic? So let me ask you this, for those of you who definitely code. What's a compiler like for you? Give me some qualities of a compiler that you enjoy.
You enjoy, really?
It was an easier question until you added the last part.
Catches the obvious errors, okay. Anything else?
Why?
Just works, right?
It depends what kind of language it is, but if it's a static language, then it's just static type checking, and variable type, then it's basically just syntax checking, and then you're stuck at that level.
Right.
Okay, so JavaScript would be a syntax checker, in my opinion, as opposed to.
I'm not going to say anything better about JavaScript. I've reached my quota of missing languages. Yay, Java.
Also, comes with optimized because
Right. So we're gonna again. So I want to submit to you that the thing that I like about my too long waiting for compiler. You may be waiting for Maven to download packages.
We aren't just having an install on that, huh?
Well,
I was gonna make the same comment.
yeah, sure. You haven't seen my water-cooled tower in which I run my soup and in which I compile my soup.
Still don't make it fast.
Well, it's fast enough. I agree. So it's fast enough for my stuff. You can, so just a quick detour. You can get Scholar to be fast enough. You just have to modularize your builds sufficiently. So we'll take it offline. That's not.
From the parking lot.
So compilers are very reliable. Okay. When was the last time you filed a compiler bug?
Oh, shoot.
Of course, yeah.
Back in the 80s.
Back in the
Oh
80s.
my
Oh, no, there's, I mean, I use Visual Studio,
Yeah.
and if there's, I don't have to, well, it's
Target
like,
rich.
it starts off bad, so basically, it's, you know, there's tons of problems with that compiler. And even GCC or Clang, I'm in the C world, those still have compiler bugs, so there's plenty of them. And sometimes the optimizer will actually, speaking of optimization, go a little carried away, shall we say.
That's called the dangerous level.
But
Not a safe level.
the trees have got much better in actual late binding.
So I agree, and actually this is a good point that there are environments where compilers maybe aren't quite as stable as others, and there are probably environments in which you really don't have the right tooling to make your functional tests really fast and really stable. I don't know much about mobile, but I know some of the mobile technologies they're really new and it's just really difficult to
Yeah.
to learn. So fair enough. There are boundaries to the thing. But this is the reason for the title of my talk is that to me compilers are these three things, and when I think about building a functional testing setup, functional testing infrastructure, I try to reach these goals, and so and then they become very useful to me. Okay, so when you have a compiler error, what do? Typically you fix it. You don't go and file a bug and say, well, we'll triage it, maybe tomorrow, or, you just fix it, right? Because that's how you use a compiler. You stop and you fix. So,
Well, in my world, yet again, you can set the warning levels at different levels.
okay.
Okay, and some warnings level going, I can ignore that, because I don't really care.
Really?
Oh, yeah.
But then that's,
Because
that's a warning then.
It's a warning level. I mean, well, to me, but you can also set warnings to be errors.
Yes.
I mean, you can say, it's like, oh, you've lost precision from going from long to int. Thank you for sharing that with me. I don't care at this moment in my life.
I said error.
Well, yes, but, well,
Yeah, but like with GCC, I think with Pedantic,
you can put wall, yes. Yes.
well, Pedantic will actually not compile it for certain things, and or if you just leave that out, you go past it.
I will admit my ignorance of GCC.
Well, also, all of them have the same issue. I'm just saying, sometimes
Yeah. So
certain errors are like, for right now, I'm willing, I mean, once I get to perfection, all warnings better be off my code.
I think it's mostly. You mostly fix it right away. Move on.
Sorry.
But you do write that, you do document it. Why did you say you can just say, oh, I don't want to document, I don't want to write about?
No, I'm just saying, the point of this, I'm trying to build my case why I think functional tests and your mental model of functional testing should be like a compiler, right? It breaks, you fix it. How many of you have builds that are rad, especially like in a functional test, that like they stay rad for a day or two?
No, not a day.
Okay, but a couple hours?
Oh.
Okay.
Yeah, we have flaky tests.
Okay. So this is kind of where I'm heading with this, is that I've been in a lot of places, the consultant I show up and the builds are rad for days, and people think it's okay. It is not okay. Your functional test should be providing you value immediately, and if they're flickering, etc., typically you want to take some aggressive action if you're just not getting the value that they should be providing. So this is where I'm sort of getting on my soapbox and telling people that you really want to do this. You want to do software by creation, right? You want to start with something that works, add a little bit to your software, write some code, and then do the test, you go through a pipeline, so you compile, unit test, functional test, and if you fail, you roll back. And you don't let bugs sit in your code base. Typically I give people about 5 minutes, because sometimes they just forget to check in the file. You're like, okay, you can go and check in the file again.
No, you don't let bugs get into your code. There's a difference. There's a big difference. A lot of these CI things are commit then test, not test then commit. There's not that many people doing test then commit.
That's true. We have slides on that. And I'm gonna get to that.
I'm a page still. I'll take my payment.
I don't know.
Okay.
Right. So the idea is that at least kind of get to this level where we'll talk about the next level of where you can even do testing before you commit, right? Pre-commit testing. But this is to me kind of the minimum. If you're going to invest in automated testing, you should be practicing this, because I see very little value in doing it in any other way. Especially again, if you're trying to reach continuous delivery, if you're in a different kind of business and you're not in a hurry and you can afford to do it a different way, that's fine. There's a context to this talk. I don't want to say that people are not doing the right thing in their context. But in the context of continuous delivery, if you move there, you want to be good. So branch by abstraction is another technique that can help you to deal with this. And the idea is, again, you check in code in very small increments to make sure you didn't break anything, but the feature that you're working on may not be ready. So branch by abstraction basically means that you have flags in your code where you can hide pieces of your functionality and not bother exploratory testers and not surface it to users, but you don't have to work on a branch for too long, right? So in continuous delivery, there's this idea of feature branch is evil, and you're supposed to live on the trunk, right? You're supposed to check in code into the trunk very often. So we use the term story branch, where we work on a story, and then try to integrate it, and then delete the story branch and work in very small stories. So this is what this is about, and this is one of the techniques that helps you to not be afraid to work in small. So a lot of the many times what I find when I visit my clients when I was a consultant is that there's this fear of integrating. There's a fear of checking in code because you're going to check in code, it's going to go red, and you have to do blah 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 all this stuff. So you have mental defenses to minimize the pain. You try to check in a big thing, which actually is exactly the opposite of what you want to do. Right? You want to learn to write 10 lines of code, check it in, make sure it didn't break anything, yay, and then you can go home with normal hours and know that you did not break the code. So branch by abstraction is something that helps you with that. And microservices, what many companies are moving this idea of microservices, I think it's a natural fit for this because again, you have a certain level of isolation and you can, you basically, as long as you're backwards compatible, you don't even need any kind of flag because you can add to your API, right? And not worry about checking your code, as long as you're with that. All right, so the next thing I want to go over is sort of this idea of what is quality. And I really like the definition of Jerry's, quality is some value to some person. So basically, it's in the eye of the beholder, et cetera, et cetera. And this is important because as we're making engineering decisions about what it is that we are going to test or not going to test, what are we going to automate, we can use that idea to inform us to make the right investment in automation. Right? It actually is easy to overinvest in automation, and again, it can be slow and unreliable. And one of the culprits is you didn't really analyze your true risks, and you overdid it, and then you're suffering because it's slow and unreliable. So having the right number of tests to manage is also important. The other point here is that this is kind of moving towards the idea of DevOps is, who owns quality, right? It's definitely not QA. It's the entire team who's on quality. Because from the customer's point of view, they don't care how you guys organize yourselves, right? Who's developer, who's QA. all they know is their stuff doesn't work and they're not happy. So, you know, having this kind of a culture is really, really very important to succeed in this. Stop committing code. Just think about it. Okay, code is not always good. What you want to commit are units of business value, right? So you're building your software incrementally. If you just commit code, you actually could be pushing back on the value you're delivering, because you can be committing bad code, untested code. So think about that and agree, you know, build a culture where you agree to write the right number of functional tests with the code and commit everything together. So the big problem that I see is people saying, yeah, we'll automate later. We have this, you know, this team, they'll come later and automate. And, you know, again, it may work in some contexts, but in the context of continuous delivery, you really want to do it right away and then enjoy the benefits of that regression immediately, right? Because again, you're moving very fast in small pieces. You really so typically in this environment, you have testers and developers collaborate. You write the automation together, and then you check it in together. That's why I found that works well. So, any questions before we? I know I've been going kind of fast, but they're good. You want to build the right thing. So you want to start with business-facing tests. So unit testing is often described as a technology-facing test. Brian Merrick has this nice slide, which I probably should have inserted here as well. So there's tests you write as a developer to help you with your specific unit, and the tests may be quite technical and using various esoteric data structures and monads and partial functions and other things that business people really can't understand. But then there's the business-facing tests that are pretty simple, right? Here's my starting condition. I'm, you know, with the purpose to accomplish this goal, I'm going to do A, B, C. Bingo, I accomplished this goal, and this is what I need to check to make sure that this business goal has been accomplished, right? So business-facing tests are very important because that really helps us to build the right thing. It helps us to reach, sort of, to cross the communication gap between business and technology. So, and to me, that's why originally this talk was named integration tests in compiler, but then after talking to people, I realized, no, this is really about functional. It's functional, it's business functions, right? You have to express that. So I'm focusing on that. Behavior-driven development. So I'm curious, how many of you do something like Cucumber for reals? Anybody doing Cucumber for reals? Okay, good. So interesting. I've had kind of similar issues with tools that try to really help you with behavior-driven development, but they themselves are pretty heavy, and so they put a heavy burden on you. In many projects I've been at, and personally I've moved back to still doing behavior-driven, but using much simpler tools. You know, sometimes just naming your functions well and decomposing your functions in your tests is good enough, depending on what you're building. If you're building something that's fairly technical domain anyway, then your SMEs or your product owners are pretty technical, and you can sit down with them and go over that together and say, this is kind of what we're building, and say, yeah, that's about, I think that's right. And so you can automate, but you don't necessarily have to spend a lot of time with, using tools like Cucumber. Maybe in some contexts they work. Again, I'm not here to this all the tools in all contexts, but in my context I haven't seen that much. A guide where we had actually a lot of conversations with management about maybe moving to something like Cucumber, and they pushed back, and I think, yeah, it worked fine. I mean,
I built prototypes.
Huh?
I built prototypes there. We had
yeah.
we can put in the production.
Yeah, so there was a lot of pushback from people that now they felt it was too heavy. So to me, I think it was a learning experience. So yeah, it's probably too heavy a tool in my. And again, I do my automation based on risk analysis, right? I mean, you can't automate all the various flows and exceptional conditions for complex systems. It just gets too much. It's not affordable unless you're building something where you actually have to automate at that level. So you have to choose. You have to choose wisely what you're So here's an interesting topic. How many of you have done a lot of mock objects with your, and how many of you lately have read some articles where people are saying, ooh, we overdo this mock object stuff. These guys are mockists. They're mockists. And we're not mockists. Have anybody followed this whole? There's been some interesting.
Machiavellian?
Machiavellian, exactly. Yeah. So this is something that I sort of fell into myself, and this is a big chunk of this talk is to propose that yes, mock objects are great, and you can make your tests run really, really fast, but at what cost, right? My mock is only as good as my understanding of what I'm mocking, and when that thing changes, I mean, even if I got it right the first time, when that thing changes, right, how do I know that I not have to go and fix my mock? And even if I know, it can be pretty tedious to go back and fix my mock, right? I just need to know that whatever thing I'm mocking changed and doesn't work anymore. So,
That same argument can be made for testing in general.
fair enough. But,
So we're done?
so we're done. So we're done.
No, the difference is
But-
that if
but the-
something happens in testing, the test breaks.
Yeah.
Right?
No, my point is that the code is changing so quickly, you can't afford to maintain the test.
Yes. Yes.
But
I
then wouldn't the
agree.
test break? They'd be read. Whereas if a mock is
Presuming that there are
broken,
tests. So I'm saying that if I have a team that's working on stuff that's changing so rapidly, like entire screens are rewritten overnight, that they tried to write some new tests and they decided it was not worth the effort.
So if you are changing the code and you are changing then those tests needs to be rewritten, right?
No.
They cannot have the same test run on the new code, can that be?
No, so they basically stable test it, broken, they'll fix them, they don't write new tests.
but
So
then
why
this
would they write, sorry, why would they write a new code but not change and use the old tests? I don't understand that thing. Why would they use the old test to work on? How can the
Let's
old
make it
test?
clear, like the developers versus QA, we have complete automation regression testing in QA, right? So there is some level of testing, right? The developers choose to know, it's been really hard to sell unit tests to developers because when they've written, whatever unit test they've written has quickly broken, and it's just an overhead because the code that's being tested by the unit test changes so frequently.
Okay, but there are external interfaces that are more stable?
Well, I mean, this is part of a microarchitecture thing, and it's different,
Right.
it's just the UI part.
But my question is there any layer that's stable enough to warrant automation, or are you just moving so fast you don't need any automation?
Our QA team automates for each release, the pages that users will interact with, right?
Okay.
At the page level.
Okay, and those are pretty stable, so they actually get the value, or?
No,
Can't be,
they,
yeah.
the QA team keeps the cost of when those pages change, which they do every release, and we have a very, like, we have a 4-week release cycle. So every 4 weeks, a lot of pages change, QA has to rewrite their test.
But within those 4 weeks, is there enough stability for you guys to get any value?
From the test.
Well, from any automated test. Are you getting any value from any automated test? I get the unit test, things change the test, okay,
I
got
think
it.
the company is, but the developers aren't.
So the test that QA writes, they're stable enough, and they're catching bugs, and you're getting value?
Turn left.
So the reality is that we do like 3 weeks of development,
Okay,
and QA just started testing, and then we start fixing bugs, and then they start writing automation, and then we redo all the screens. And by the time that the automation's done, the stuff that they're testing, a lot of it's changed, and they have to rewrite the test.
okay, I get that they rewrite the test. My question is, to you as a manager, are you getting any value? Are you catching enough important bugs? They probably catch a lot of bugs by exploratory tests.
Yes,
But in terms of automation, are you getting any value of any automation in your place?
I'd say much less than an exploratory.
Okay, but is the ROI even positive, or do you think it's just, are you going through the motions of automating without actually getting enough value in terms of the salary that you're paying?
That could be, but
Okay.
I'm thinking the tests that are being written are too brittle. I think that's just by definition. And if that's the case, then my suspicion is that they're not writing the right tests.
Why would you blame the testers,
No,
when
I'm,
the code is changing the
well,
history?
first of all, I don't blame anyone, you know, it's just.
No, 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 I'm
It's the
just saying.
engineers that are writing these tests, and I'm thinking from my experience, I've seen a lot of engineers not know how to write good tests.
Do the engineers ever write tests?
They tried, but the reaction to what they ran into is as soon as they wrote their test, and then they implemented the next feature, the test broke, yeah.
So they do write tests?
They write
No,
tests,
they
but then
did
it
write.
breaks it like immediately when they make another change to the
Oh.
code. So the test is too brittle for what they're doing.
It's probably a special case because we're doing a lot of, this is very bleeding edge JavaScript development, writing React components from scratch, right? So we're writing like combo boxes and weak components, we're writing very low level components. And the requirements of those components is changing constantly. We get feedback loops, right, from people using, but it's all exploratory. All the value comes from exploratory testing and feedback that way.
Like
By
I
the time
said,
the automation kicks in, it's kind of late.
yeah, so we're in perfect agreement, except this talk in a way is about exploratory, because to me, the value in your functional testing is to get you to a point where exploratory testing is the final gap, where you're closing the quality gap, and that's kind of what, so, that's kind of where you wanna be in most cases,
Is it,
so.
is it Noel or Noel?
Noel.
It is Noel, okay. I wanna get back, I wanna ask you the question, follow on what you said. I haven't ever had to do, thank God, I've never had to do any UI automation myself. But the absolute book on that from everyone I've ever talked to anywhere, and we're talking dozens of places, is that is the most brittle type of automated testing that exists on the face of this
I
planet.
agree.
So it sounds like you've been in that world. What have you done to mitigate that issue?
I haven't been in that world because I don't want to face those problems. I've stayed away from that world because of that issue. So the problem,
He quits
I
and
think,
moves
is that
on.
you're right, the UI tests are too brittle, and that is that's the biggest problem that needs to be solved in UI testing. It hasn't been solved yet.
So where is the root for it? Any idea? You guys, you do
Oh, what
this
are the
thing.
problems?
Who is the root? Engineer or?
Well, from what I've seen of UI, right? You create a UI, the dialog box should be over here. You run a test to make sure that it's over there. You know, a day later it moves by a pixel or two, and the test fails. Right? I think testing is better than that nowadays.
Well, so take that multiply times 10 or 100.
Right.
Because it only fails in Mozilla at a certain level.
Yes.
Right.
They have the matrix problem.
Or like you drop a combo box, when you navigate to the page in some browsers, it opens before you click on it.
Yeah, you
have
have
to click on it.
CSS issues.
And then it doesn't close when you click outside of it. And then the keyboard nav doesn't work. There's like 100 different ways for that simple box to fail.
Right.
And it fails in 5 different browsers in different ways.
Oh.
And it's like whack-a-mole.
Yeah.
Every time you fix one of those things, we'll see
It
it
breaks in
here, a
another
little JavaScript
browser.
there, a little if I10 here, then it breaks another one. And then automation only tests like certain main paths through certain main browsers, and it doesn't catch all the possibilities. And then exploratory
Unless
testing, exploratory testing using 5 different browsers does catch most of the things. And unfortunately for us, we can fix each of those things very quickly.
So it's a yeah for manual testing?
Yeah.
UI is
But
still pretty manual, and mobile too, from
Yeah.
my, you know.
So that's kind of where I wanted to get to, is you have to figure out how to get your functional tests fast and stable to get value. Otherwise, you might as well save your money and invest it in better exploratory testing. Now, I'm going to digress a little bit. You can have a mixed approach. So, for example, you can have automation that drives your code kind of like these journey tests, right, through a lot of browsers and source labs, take screenshots, and then have people look at them and say, oh, combo box weird. Because people are really good at looking at patterns. Now, there's new software coming, I hear, I haven't used it yet, that actually is also pretty good looking at patterns. So you may be able to automate even further, saying, go look at this screenshot, it probably looks weird. I think I've heard people use, but I have never used that software myself. But I hear that there's some kind of artificial intelligence software able now to look at a screenshot and say, that looks weird as well.
Oh, wow.
But so that's kind of a combination approach where, again, automation is solid because all you're doing is you're just kind of going through a couple of screens, and you can set up typically your navigation. If you engineer the property, you have stable IDs, right? So even though the layout may change, right? The idea of the button to click to move to the next page can be stable for a very long time, and so you can automate on that.
Right, and we do, and we
Right.
use Selenium.
Yeah.
And FID.
Do you guys take screenshots and have people look at the screenshots?
I don't know, they might. I don't, I work directly in that.
So that's an approach where you can mix some animation with some exploratory to close, just for the look and feel. Just for the look and feel. Yeah. Again, so that's that. So I think this conversation really hit the point where, what is the definition of insanity? Doing the same thing and expecting different results, right?
No, that's a definition of someone who understands probability.
Yeah, question.
Yeah, I was thinking again in the Scrum scenario where you've got, as you said, developers and testers are collaborating. And in fact, developers should be gaining some of the QA skills so that they are themselves cross-functional and they're developing with an eye on tests and a good understanding. Yet developers can't write tests because they write it too brittle. So, I mean, this is what I'm just gathering up what I've been hearing. So is this just again initiated, or eventually they learn from working cheek and jowl with good testers to write less brittle
Just
tests?
to clarify, the developers are pushing back on the governance of the unit test, and the QAs are successfully getting some value out of function tests or regression or integration tests, automated tests.
And the consensus here was pretty much, and feel free to pounce on me after I say this, is that nobody can write non-brittle UI tests, or effectively no one. That's an industry-wide problem.
all right.
That it's not QA people, it's not developers,
It's yours.
it's just a hard problem because the tool sets that can detect those kind of changes aren't themselves clever enough to know that, hey, this is just a logo change versus this is a debilitating change of something that was supposed to be there. It's just looking at a blot of bits on a screen and trying to decipher that.
You can't loosen up the precision.
People do all of the obvious things that any of us in this room will think of have been tried decades ago.
Okay.
I mean, it's a well-understood problem. There's lots of really smart people working on it. It's what I call a deep CS problem.
Okay.
You get, it's a PhD level problem that needs to be solved by lots and lots of people iterating over years.
Also,
We're not there.
Does my web application, while it has the normal aspects of the front application list, detailed views, also has D3 SVG graphical things with a lot of graphs with repositionable lines, a lot of states,
Yeah.
right, and colors and stuff, right? So, and pixel perfect is something that, I mean, if things look off, we fix that, right? So, there's so many ways, there's so many kinds of bugs, and we call them opinions, actually. People write a bug in Jira, and it's because I think you should do this, and nobody else has stated an opinion one way or the other before that, so therefore, we have to fix it.
So fair enough.
Yeah, I just remembered, for the past 2 years in GTAC, there have been talks regarding UI testing. I don't remember the details, but anyone interested, the talks are on YouTube.
Okay, so I think we made that work for a while. So the key point I want to make on this slide is that speed is king. If your tests are fast, you'll be able to figure out what broke just because, you know exactly which check-in broke your test. Maybe you have a couple of check-ins in your test cycle. We'll talk about that. But ideally it's only one. So even though it's not as easy to comprehend what broke just by looking at the result of a functional test, because it's in the context of only this thing changed, you can easily deduce what broke most of the time. So some people make an argument that you need unit tests because otherwise it takes too long to debug the information from functional tests. Well, not if they're really fast and you're only testing a very small number of changes, or ideally just one little change. Okay? So they're slow, but we have the cloud these days. Yay! So how many of you are using the cloud now for testing? All right, half the room. Okay, so again, the point that I want to make is, yes, we'll talk about spending some money, right? Because when you get to the cloud, it's very easy to spend some money. But remember, if you have a team of any size, what you're gaining by making that investment is that you're saving people time, because the time between sort of bug introduction, bug discovery by these regression tests is very short, so people don't have to come back and figure out what was the context when they did this bug, it's still in their head, right? So we're talking about moving the feedback from functional tests from hours or days to minutes by using the cloud, by parallelizing. That's what we're about to talk about. So I did some calculations, and maybe it's even cheaper right now, but basically from last time I checked on Amazon, I can run the 100 instances for $30 an hour, right? 8 cores each. So if I'm using Docker or something to containerize my testing, I can have 800 cores for $30 an hour. That's a lot of power to run a lot of functional tests. And as we discussed, we're not going to go crazy with the number of functional tests that we have, because we're going to have a reasonable number, so you can get results very fast for a reasonable amount. Source labs is another example where they're very reasonable for reasonable test case. You get good info from them for reasonable amounts of money. There is a bunch of new CI tools out there that are all cloud-based. Again, they have various capabilities, they cost various amounts, but given the cost of developers in the Bay Area, typically it's a good idea to use one of these if you can, unless you have some issues with putting code out in the cloud, in the public cloud, in which case you have to spend more money because you have to build a private cloud.
So the only one of those I've heard about is Sauce Labs. Can you give the
So
one level bullet point of
Sure.
the other guys?
Sure. So Travis CI is pretty famous because they run a lot of open source projects.
I've heard their name.
Yeah. And typically most of these new services, you configure them through YAML. So you can, because again, thank God it's not Jenkins where you have to do these weird configurations. You have a nice clear YAML file that you check in with the project, and in the YAML file you say, okay, I need Java 8, I need Maven 3.5, I need this version of JUnit, I need this and that, and then please parallelize me, 20x.
Okay, your semantic grammar checker threw a flag on YAML and clear in the same sentence. That's obviously a grammar error.
But you're no stranger to having a web UI with a bunch of config things which are then stored somewhere else.
So first of all, I forgot to mention, what is
I
YAML?
got one laugh on
Let's
it. Yet another markup.
So it's a pretty simple textual language where you can express some kind of tree-like information.
It's the bastard child of Yak.
So maybe there are better ways to express what it is that you want your CI system to do, but trust me, it's much better than having to dig through Jenkins, configs and Jenkins pipeline.
I thought Jenkins was basically XML backed.
Well, yeah, and would you rather hack Jenkins XML, or would you rather declare what you need in YAML? That's up to you. I know that would be.
At the highest level, they seem to be relatively equivalent.
Well,
They're both evil in their own way.
I frankly think that human eyes are not meant to read so many brackets. That's just me.
Well, you're not human, so what's the problem?
I knew this was coming. So what's interesting is that all of these companies that are independent obviously of each other, that somehow they all agree that it's YAML. Because so at Google we use Python. At Google we use Python to specify the build pipeline, which is also quite nice. Just a few pieces from Python because it has some nice lists and that was nice. But anyway, it seems to be YAML. It seems to work reasonably well. And basically, they will maintain all the infrastructure for you, and they'll just charge you. So they have various plans or various pricing strategies, and the more you want your stuff parallelized, the more you're going to pay. But again, for most cases,
In the case of browser stack, it's more about having access to all, so many different versions of the different browsers, right?
that's fair enough.
Which
Yeah. But
is
I think they
You
also
get a lot
allow
of
you.
laptops
Yeah.
in your, if you do it locally, right, you do a lot of machines.
Yeah. So browser stack competes with Source Labs, and yeah, these guys are more about just the browsers. The others are just about running your entire essentially CI pipeline, and they integrate with each other. So you can use Source Labs with Circle CIs, Source Labs with Travis. But the key here, again, I didn't want to get into too many specifics, but these are kind of the new generation of CI tools and testing tools that are in the cloud that will allow you to achieve speed. Because as we agreed, if you don't have speed, you're not like a compiler, and therefore you wouldn't qualify for this stuff. So we're talking about, we have to get speed one way or the other. This is one way to get speed is by massively parallelizing your functional test. I work at places where a single functional test can take 2 or 3 minutes easily. And if you have 1,000 of them, well, you kind of messed up. But if you have 800 cores at your disposal for $30 an hour, now we're talking 5, 6, 7 minutes to get your results back, because if you can parallel. Now, of course, that means that you can deploy your system under test in probably some kind of clustered way, and you can deploy it reliably, right? So again, we're getting back to this idea of DevOps skills. It really is a prerequisite for this, because the system under test needs to be able to handle the load that you're producing in. So I mean, honestly, for reasonably complex systems, getting here takes a fairly sizable investment, both in terms of the infrastructure, but also in terms of engineers for putting this together. But I've seen some good results over the years. I went to a Facebook talk about 6 months ago, and they said, oh, we run all of our Selenium tests, and the number is secret, it's a lot, in 10 minutes. We have a special data center for running Selenium tests, and we run in 10 minutes. We can do it. So, and they run them before they check in, before they merge into the trunk. And then they run them after they merge into the trunk. So, they've done it, well, they're unicorns. Again, at Google, we did very similar things. 8, 9 years ago, we were able to parallelize our tests, and we kind of started achieving similar things. So this, there are companies that have accomplished this. There are companies that have tried and failed, some reasons for the failure was, I guess, lack of engineering pragmatism. They just, we want to do this. No, you can't do that. No, we want to do it. Well, okay. You can't handle the truth, right? So you need to find the balance. You need to figure out what you as a company can afford to achieve this level of reliability and speed. But usually most companies these days, you can get something. You can get enough to really start practicing this kind of behavior and getting benefit from this kind of setup. Okay? So elastic compute capacity. One thing, if you're using Amazon, one thing you can do is you can buy what are called spot instances from them, make it even cheaper. But even if you get regular instances, it's still fairly cheap. But some of these tools, they will give you an option. Do you want to use spot instances? Now, what it means is that your testing framework is resilient to infrastructure failure. But it should be, because when you go massively parallel, you're always going to have some kind of infrastructure failure. So your testing framework needs to be smart enough to rerun your tests. And your tests, as we'll see further, have to be smart enough to be idempotent, so you can rerun them and still get the result that counts. Now we're getting into, okay, there's additional cost, there's additional engineering that has to be done to achieve this. Okay, so we have to work at it a little bit. So tests have to be reliable, and you need to have a hermetic build. Has anybody ever heard of this concept, hermetic build?
I used to work at Google.
That's right, we started. So give us a definition of.
So in a perfectly hermetic build, it's I consider it very similar, not exactly the same as in functional programming. Everything that you put into the system, you'll get the exact same thing out. So if your build references stuff on the file system, for example, that will likely not, or I shouldn't say file system, let's say in /bin, that's likely not going to be a hermetic build unless you can ensure that /bin is exactly the same across all your machines.
Yep.
Same goes for environment variables, flags that get tossed into the compilation and build, everything.
Yep. So basically, I think that you want to start with
The
automated.
benefit is that it's like MapReduce, the functional program. You can now spawn out all your jobs across a whole bunch of machines, have them work in parallel, reduce them back, and get something that you want.
So the bottom line is that whatever you're testing, right, the system under test, has to be pristine every time and in every place, so you get consistent results. So it's actually very common sense. And obviously, so again, often I show up with a client, our tests are flaky. What's going on? Well, we're running the test, but these QA people, they go and they change something in the same environment. What are you doing? You can't have people changing things from under you, right? Like, well, we don't have any other environment. That's the only we have. Okay, how much are you paying for developers? Okay, you have 100 of them. Why can't you afford more environments? Let's work the numbers. Tell me. But often the decision of how many environments they can have is an accounting function. They put it in the budget, and this is what we planned for. And so you have these mismatches in the organization where they're paying a lot of money for people to do work over and over and not to be productive, and they saved they saved $1 million because they cut down on the amount of resources we're using for testing, things like that, goofy things. So you wanna control. This gets back to the environmental variables and file systems, etc. You want to control everything for scripting. So of course now it's very popular with DevOps. You have Chef, you have Puppet, you have all these tools to do infrastructure scope, right? So everything is completely scripted. There's no Snowflake. Anybody know this notion of Snowflake? Okay.
Oh, there is a fabulous definition. It's become my new favorite word.
Go for it.
It's on Urban Dictionary. If you could look up special snowflake on Urban Dictionary, it's 2 paragraphs. It's worth finding. Oh yeah, there's not even a rude thing in there. Special.
But I'm not on the internet. I'm doing this from.
Keep talking, I'll look it up.
Yeah,
We'll
we'll
just
just
wanna find it.
I can give you
On Urban Dictionary makes me a little nervous.
Yeah, that's okay. It's only 2 paragraphs. I can read it. It'll be funny.
Oh no! I have to go to the. I don't know how to use this tool. Here. How do I move this around?
You go on the sidebar.
Well, oh, here I can find the title. Okay. I just got a Mac. I've never used a Mac before.
Okay, special snowflake syndrome, a malady affecting a significant portion of the world's population, wherein the afflicted will demand special treatment, conduct themselves with a ludicrous, unfounded sense of entitlement, and generally make the lives of everyone around them that much more miserable. The danger of this disease is that the sufferers rarely, if ever, know that they have contracted it, and continue about their very merry way under the assumption that everyone else is the problem. This condition, if left untreated, can radically alter the carrier's demeanor to include any one of the following: a complete devolution to childlike behavior, temper tantrums, and/or fits of narcissistic rage. When confronted with an individual suspected of harboring special snowflake syndrome, one's best course of action is to run away. Further attempts at educating the carrier on the reality of their condition, e.g. quoting Tyler Durian, "You are not special, you are not beautiful or unique snowflake, you're the same decaying organic matter as everyone else," will likely prove futile and potentially hazardous to the informer. So, I work in a place that only has special snowflakes. And it is, for the last 2 months, that has been the term of art around the people around here.
All right. I'm not going to ask you where you work because we're being recorded.
And
I want you to keep you a job.
it's also very related to Stockholm syndrome.
Right.
So those 2 things go hand in hand.
Yeah. So basically, oh, I'm going the wrong way, the wrong button. I like to think about basically these are the 2 prime ingredients that you need to get right to even begin to get there to get a hermetic build. There may be some others, but.
So on the hermetic build thing, I get that that's the goal.
Well, I don't think it's the goal. I think the goal is to get fast and reliable functional testing. This is just a.
And repeatable,
And repeatable.
hence the hermetic part, but it's, the things that go into making builds non-hermetic are often very subtle.
Fair enough.
And I was just wondering if you could speak to any things that like puzzled you for a long time and then it was, oh, this is why they're different. I mean, a lot of them are well known because far enough along in the industry, like we know about environment variables. We know about the fact that compiler at this version produces different code than a compiler at this version. I mean, I was lucky enough in the 80s, I worked for a company that version controlled their compiler.
So I work for a company that writes software for nuclear reactors, and we need to keep it around for about 30 years because, there are regulations from various countries that we have to follow. So we absolutely keep everything for a very long time, including all the tools and et cetera, because we have to. But yes, exactly. So you need to version everything. You need to be able to rebuild your environment precisely. This is if you have these regulatory challenges, right? If you're just a website and you only care about the last 24 hours or maybe 3 days, then you don't.
Does anybody here use Gradle? Yeah, I think I met you with Gradle talking. Gradle has this concept of encoding the version of Gradle that you use to compile your project. And that's actually a really good thing. Because if you can switch the version of your build tool and change the thing that you built.
Really?
Oh, yeah. Oh, yeah.
So there's Gradle W, right, which will actually.
Well, when you make the Gradle W file, there's a Gradle W task, and you say Gradle, you execute that task, and it makes the prompt, it says, hey, I use this version, blah, here's where it is to get it, blah, blah, blah. Yeah, it's a good step in the direction for making things hermetic. But there's plenty of other ways that's not enough, but it's a good start.
Yeah, and again, the one thing that I found that is necessary is if you're doing any kind of integration with external services and you can't control them, then you have to write simulators that you can control, right? Because you can't run functional tests with consuming services that are fundamentally not under your control.
You can up to a point, and then they cut you off for denial of service attack.
There's that.
But wouldn't the simulators have the same issues as mocks?
They do.
Oh.
They do. That's why we talk about pragmatic engineering decisions. And because again, the idea behind functional tests as a compiler is don't make me think. I've made the investment, right? I put everything in place. Now the information I get is reliable, 99.9% of the time. There's other kinds of testing I'll be doing, right? I'll be doing exploratory testing with the real endpoints, with the real services. There's other kinds of testing I'm going to do. But for what I'm proposing is if you're going to do functional testing this way, then you have to get yourself a hermetic build, one way or the other. And maybe you can. Maybe this doesn't apply to you.
Yeah, how are you differentiating simulators and mocks and fakes and?
Well, again, in this case, I'm mostly thinking about. So essentially, the idea is that for whatever your functional tests do, this thing needs to represent how those external systems would respond, right? So you have to configure them. It's essentially mostly like a mock object, similar mock object.
It's like at the network example, this would be JSON over REST API.
Yeah.
Yeah.
So I mean, with mock objects, sometimes the mock object also tests to make sure that the code you made is what it expected.
Yeah.
Right. So I guess in this case, maybe it's just more of a simulator. In most cases.
So more similar to like a fake.
I guess more similar to what it
Okay.
yeah. So I stand corrected. But again, maybe you do want to make it come up. It depends on the purpose of your testing, and you could go either way. Again, this goes back to your test strategy and where are the risks, right?
I guess potentially it could be an old version of the thing that they're
Yeah.
actually using, right?
So you know, there's depending on your situation, there's companies that specialize in building these simulators for you. The companies, if you're in like an ERP environment, if you're integrating with mainframes and all these things, there's companies that specialize in building these things for you. So they're specialized companies. But the idea is that you need to have it to be in the ballpark to start playing the game. Okay, so practice DevOps culture really helps. Infrastructure as code, these are the usual culprits here. Docker is really becoming a favorite of mine if it applies to what you're doing, because I for one really like writing Docker files much better than either Puppet or Chef, and if it works for you, and to me it's much more efficient as well in terms of using infrastructure. So I've become big fan of Docker. We're using Cloud Foundry, which is kind of similar to Heroku again. With Cloud Foundry, for example, you don't have to worry about fundamental infrastructure at all. There's no concept of VM, for example. You're deploying an app, and you can scale an app, and it just does it for you, and you bind it to some service like a database, and again, you never see any physical hardware or VMs or anything. So if you're at that level, it's really helpful and very, very convenient to be able to spin up environments, because really you just do it with simple manifest files and a couple of calls. That's after you have Cloud Foundry configured, which apparently requires some crazy expertise that's difficult to get. But once you have it, it's nice. You know, various orchestration tools, depending on how complex the thing under test is, you may need to orchestrate.
You run a Docker on your Mac?
Not this one, but I have.
But I mean,
I use Ubuntu Docker.
Yeah, right, if you use it in Vagrant, virtual Docker in Vagrant, you use Docker.
Yeah.
You can't run Docker native in a Mac.
You can't run Docker on a Mac, you have to run a Linux. You have to run a
Okay.
VM on Linux. Yeah.
all right, so
It's
that's
coming apparently, but it's not yet. It's not yet there.
kind of a speed bump to play with it locally.
Well,
VirtualBox.
and that would,
Well, I have VMware, I mean, I've been using that for years, that's not, it's just more stuff, more infrastructure to do between me and what I'm trying to do. That's
so let me share my experience. I found Ubuntu Docker to be very useful. I actually used a client on a Windows machine, and it worked quite well. And especially, the first thing I did is I put Postgres into Ubuntu Docker, and I'll talk about that. And then I was able to do things like version the entire Postgres database state that corresponds to a certain check-in in Git, right? And then my tests are really fast, because what was slowing down my tests is I had, if I really want to do a functional test with my Postgres, I had to bring Postgres to the right state. So I had to load schema and load sample data. This way,
You do that with a VM and snapshots?
but how fast? The Ubuntu Docker was doing it for me in like a second.
No. I don't wanna steal this, I am interested in that, go ahead.
No, but this is part of it. I have slides on that.
Okay.
This is part of it. In fact, I think it's maybe coming up. So yeah, let go. Put your database into Docker. Amazing, right?
Like I said, page shelf.
Yeah.
Right here.
Faith.
I knew what he was gonna talk about before I even knew it.
So so let's continue the discussion. So a compiler is incremental, right? Maybe not Scala so much, but a fast compiler like a Java compiler, which I love. I love Java compilers. Good product.
Are you making him happy?
Huh?
Are you making him happy?
No, so I actually wrote a Java to C# translator,
Oh,
and so I really had a Java compiler to do that. So I truly love the Java compiler. It's simple to work with. I don't like the Java language because it's got all these curly brackets with them, semicolons, and really horrible generic syntax. But the Java compiler is really easy, and it's very reliable. It's very quick. And also it's quite incremental. It's quite the Java compiler. So like with the Scala, you have to do a little more work trying to modularize your system, because if you just throw a whole bunch of Scala at it, it does get kind of slow. But the Java compiler, even for large code bases, is pretty fast, because they've done a good job at making it incremental. So we want to make our functional testing also fast and incremental, because we care about speed. So using Docker for your database is a great trick, because you can get your database at some commit point, and then just execute the schema migration and execute additional sample data that you have to load just for that initial commit, which usually is just a little bit, right? And off you go. So essentially you're simulating what you would have done in a production system, where you wouldn't load your database from scratch. You would just use something like Liquibase to apply your schema changes and load maybe a few more C tables or some sample data that your test needs, and you're in good shape. And so what we've done is we have actually an asynchronous process that would run these Liquibase migrations on Postgres and then Dockerize it and put this Docker image with the right version number into a Docker registry, so then when you're about to do your build and run functional test, you have the right version database with everything loaded and available to you. Bing, bing, bada bang, start up in a couple of seconds, and you can run your functional test. Make sense?
So the thing you're talking about a binary repository for Docker images?
Registry, and
Yeah.
you can back it by artifact.
That's kind of what I was going to
Yeah.
ask. Is that what we learned? That why we went up there last week?
We went up to Napa to artifact for artifactory conference ostensibly last week. It was Napa's. I don't remember anything before, except it was good. It was good fun. Actually, I shouldn't say that because I still have expenses there. Strike that from the video. Very useful conference. It was great. I learned a lot. No, but this, I mean, I did this thing with Docker actually over a year ago, so that's not something I learned. So let's see. Yeah, so again, Docker is a great tool to get your hermetic build and to get your hermetic environment and to get there very fast. Because again, if your test is slow, it doesn't count. So this is the only picture I was able to put together. So the idea is that if you got everything right, you kind of got your system under test, maybe a little cluster, data storage, a bunch of test runners, and just all works and test them out. The other benefit you get, if you get here, is you kind of get a little bit of load testing for free, right? Because you can track how long it took to run all the tests. If it changes drastically, maybe you introduce something that, it's not formal load testing, but you get some of it, and you also get some concurrency testing if you're doing it this way. So again, this picture is for a typical sort of multi-tier architecture. If you're building something else, like if you're in the business of just UI widgets or whatever, maybe, but we can still parallel.
Well, we have to visualize complex graphs, so we need to be able to switch between very different graphs. So we need a lot of stuff on the back end to do that.
Okay, so you have some more.
Yeah.
You have some, okay, good.
So instead of test runner, it would be manual test UI.
Okay. So that's kind of the goal that you got here. You got your results fast, and so you want to make it fast, and the tests should be important because meaning you can rerun them and they will still produce the same result, right? You can rerun the test. And it's very important because often what happens when you go massively parallel, you just have infrastructure failures. You need that to compensate for that. So you need a little more engineering in your. You want to aggressively fight flickering tests because again, if your build is flickering, you're not going to trust it, and eventually you're going to lose all hope.
So there's a fabulous article on that very subject by none other than Martin Fowler. Look up Martin Fowler and non-deterministic tests, and he says that I agree with him 100% that they're evil incarnate.
Is it on LinkedIn?
And just Google it. Google
Yeah,
Martin
Martin
Fowler
Fowler.
non-deterministic tests.
Yeah, no, they're evil. Yeah, if you're not aggressively fighting them, you're not going to get the result. And it turns out, at least my experience with Google is, at least half the time, you actually have real bugs in code. Yeah, they're subtle bugs. They're catching you. You're like, my test is flickering, but because you're not aggressively fighting it, you don't really know which one it is. Right? So it's very important, as part of the culture, very important to have that sort of mentality. And again, you want to practice stop the line, right? If the test is broken, you don't write any more code, you stop the line, you fix it. And you move on after that. You may want to introduce a role of a build cop. We've done that, well, you've been on Google, right?
Yeah,
So
it's,
controversial, but sometimes it's
I
good to
think
have
it can be
somebody.
done right, and right is very subjective depending on the team and the environment. And it can be done wrong too.
So, and you know, the best is when you don't need it, but sometimes you do on large teams and complex enough. So basically, essentially the idea of a build cop is, you know, you sacrifice somebody. So some developer for the day, their job is to understand why the build is not green and dig into it and try to rally everybody to, you know, to do it. Maybe you don't need it as much these days because now if you implement pre-commit testing that Michael loves, your build is going to be that much more stable because you catch things so much. But in the beginning, maybe you should do it as well. Again, this is still a slide that assumes that you know you have so much development going on that maybe you can't afford to test each individual check-in, but at least there's only a few of them, and that's very key. If you're checking, if your test is slow and you have 20 or 30 check-ins, it's not going to work. There's too much stuff that went in between build cycles, and they're very difficult to figure out by deduction. You're actually going to have to debug. So this is why, you know, often if you just have a separate QA group and they run their automation, the results they give you may have tens or even hundreds of check-ins in their results, and then typically you just have to start debugging. So there are bugs, right? And what I'm proposing, we're not dealing with bugs. We're treating it as a compiler, where if it's broken, you stop and you fix. Bugs have been replaced, but the idea is in this scenario is not to even get to the stage of filing bugs. Your tests are reliable, they're fast, they break, you stop, you fix, kind of stuff.
You ever worked on a pipeline where they just bounce, if the test failed, they just bounce everybody out and have them try again?
What do you mean by bounce out?
Well, if it's a pre-commit test, you don't let any of them commit.
Right.
If it's a post-commit test, you revert it and you
Yeah.
take the next batch. And you tell everybody else, they can go try again.
Oh, you mean to roll back the code?
Yeah.
Yeah, that's what I'm proposing. Typically, you stop the commits and you revert. Yeah, that's exactly right. Yeah, that's exactly what we've done. Now, the question is, do you do it in a completely automated way, or do you give people like 5 minutes saying, oh, okay, you forgot a file, okay, go ahead and check it in. It depends on your culture. But, yeah, it has to be done very quickly. It has to be done very quickly. So, let's talk about how we can make our tests that important. A lot of the time, the key is don't share any state, so don't have your tests share any global variables. And if a test just reads data, great. They're by default unimportant because they just read, and your build is hermetic, everything, you control everything, the database is all set up just right. So if you test mutate data, then they have to create the data they're about to mutate. Because A, they need to run in parallel, so you can't have any kind of race conditions of this test is going to change this piece of data and then other tests actually execute that, right? So it has to create its own data, and to be as important again, it has to be able to recreate its data. So one really simple trick, if you need to do that, is you use UAD suffixes for pieces of data that may be in conflict to make them unique. And so you can keep creating data that the data will never, you know, especially for keys, they will never collide. Simple idea. Any questions on that? That makes sense? Okay. All right, so build a flickering detector. Run your test 100 times before you admit it into the test. Google that. I like that idea. Your test has to be admitted into our test suite because we're like a compiler of a solid test. So you don't just get to run your test before you have to join the club. That's the hazing or the admission criteria. All right, and you want to educate your developers. This came up several times today, right? You have to educate your developers on these strategies, how to write these tests for this whole thing to work.
you need variations on 109, because there's classes of
Very
players,
Thank you.
which at a previous
Yeah,
shared
it's a good
employer of
one.
ours,
I'll just look
they
at
were
it.
tested always failed on
I have
Saturday.
a question.
They were tested always failed in leap years in February. They were tested always failed 6 months before the end of the year. And they were tested failed when the test data got too old. Like the drivers, the test had to do with an underage driver, and the driver was graded, his birthday was picked like 5 years ago, and like last year he turned 21. Yeah, so you need more than just retest.
You need,
to-
yeah.
You need to change the clock or something.
This is a very simple strategy. Now you're getting into specific domain knowledge. So yeah, in the insurance industry, you know, there are rules that have to do with the calendar dates. There are rules that have to do with, you know, how people who get older get treated by insurance companies. Exactly. Right. But I would argue that this is where you want to be skillful at generating your test data to properly fit within those rules, and also have some exploratory testing skills to say, we need a test strategy, let's run these tests at a different time and date. And yeah, I was there for some of that stuff. But at least things were pretty damn stable compared to other. I mean, I had at least a couple builds a day, and they were stable, they were green builds, we were able to do exploratory testing. Companies of that size that get to that level, you know, I take my hat off to them. So, yeah, it was pretty good. And there you go. so yeah, this is great. If you can afford to actually run tests for your code before you even commit, or these days you merge to master, merge to a branch, that's even better. You're going to keep the main build more stable. However, if the thing you're testing is like 20 or 30 or 40, 50 microservices, and you need a whole bunch of resources, you may not be able to afford to do that. That depends, right? That becomes more of a business decision if you can afford to do that. Honestly, if you have 3, 4, 5 commits in a very fast build cycle, usually you can figure out who broke what. It's not that bad. It's much better than not doing it. So even if you can't afford to do it at this level. But for smaller systems, you can definitely afford to do it. Absolutely. I'm looking at how, I'm looking right now into how we can do pre-commits with our Cloud Foundry infrastructure. I realize we definitely are not going to get these Cloud Foundry spaces for each developer, because the infrastructure group is basically giving us 4 or 5 spaces, that's it. But one thing I realized is that, well, maybe if I write a script and use some tricks to deploy a system under test fast enough, I can quickly deploy it in a hermetic style, run the test, and then delete it all. So I can reuse the same space multiple times and queue things up, and maybe achieve something closer. I don't know. I haven't
Well,
done it.
that's a place, I don't know Docker, but that's a place, I've done things with VMs where you've
Right.
got snapshots and you can,
Yeah.
it's not quite as pure as what you said with UUID key suffixes and all that stuff,
Mhm.
but you can run a series of tests against a well-known starting point, you
Yep.
know, well-known initial conditions, and then snap it back with a snapshot and run a different set of tests with the same initial conditions. So you've invested, it's kind of like Puppet and Chef. You invest a lot of time in the setup part, but then you can just rail out that thing that's set up exactly the same way over and over.
That reminds me, there was somebody at Guidewire years ago who started working on something using VM images. I remember. I don't think that ever came to fruition, but yeah.
There was perfect, yeah.
Yeah. So again, this is where we turn to our friend from Netflix. But what do you do when you have hundreds of these microservices? It becomes difficult, right? Like what's the system under test, right? So you have to be pragmatic. You have to compromise.
So what about the other factors, the other environmental factors, and something other factors? They don't interfere if you have the same test running, same initial test running for different, you said just now that you take a snapshot and you do the same testing again. You use the same test suite again and again on different builds or different releases or what?
Are you talking about flaky tests or just?
What people saying just now?
Well, so, a lot of tests, you know, any big enterprise system, I mean, I work in a company where we've got, you know, a large enterprise system, and we don't want to start with an empty system and populate it from nothing. So our developers write tests against well-known data sets, right? There are these employees, and their names are this, and blah, 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 and if the data is this way, when you come up, and you're guaranteed that when your tests come up, it's always gonna come up with the same initial conditions, you can write tests that can use that data. Now, maybe your test is gonna muck it up for me. But that's okay, because when I come in, I'll just hit the reset button, and I'll get the same initial conditions you had, and run my tests. Now, maybe you won't interfere with me at all. I don't know, I don't care. I'd rather not even worry about it, so I'll just hit the reset button, because I don't trust you. It's not you, it's me.
So this is for manual testing, right?
No, this is for test automation.
But, okay, but how do you guarantee only one?
Yeah,
You snap it back.
No, how do you guarantee that there's only one automation running in an environment at a time?
And
Do
you're
you have any,
talking about
do you have any
QASource,
contention?
right?
Do you have any contention, or?
It's like your Docker image, right? I've got a test, I have a
Okay.
test runner
Okay, so
that
you have
says-
full control of
that
the
that says
environment.
run a test,
Okay, sure.
reset, run a test,
Okay.
reset. And if you can do that fast enough, that's a reasonable way to do that.
I'm hearing, okay, but, okay,
Well,
does your setup guarantee that nobody else is gonna mess up with your thing? Do you have any race conditions in your setup?
Friends don't let friends share test environments.
Very friendly. Okay, got it.
the
So I
keyword,
just
does
wanted
that
to-
work, really?
You aim for it. I mean, sometimes it's hard to get there 100%. You know, work towards it.
Maybe keep a baseball bat at your desk.
So one of the things you can do to make this more of a reality is that you only run selected tests, right? And hopefully you catch most of the stuff. So the idea is that you can basically look at what actually changed in the system under test and choose what test to run. So therefore, you're reducing the amount of time you're going to run in your pre-commit, so you can afford to do more of that because you're not using as many resources. And there are some simple strategies, depending on how your system is modularized, to just run those. Now, you may miss some interesting bugs, but that's fine. It's a compromise, right? This way, you may be able to afford to run pre-commit.
I have a question.
Yeah.
The pre-commit that model, I've never heard about it, but the pre-commit model that you're talking, is it an agile environment?
I'm the wrong guy to ask about the current terms that are in vogue. But the pre-commit idea is a lot of CI systems you'll check in code and that'll trigger the build system to say, oh, let me go see if it actually works. Too late. Because then somebody checks in on top and somebody checks in on top of that, and that's really hard to detangle. Whereas reverse that paradigm and say, tell me what you're going to check in. I'll lay your stuff on top of the existing code and run the tests, and if they work, if and only if they work, then I'll check your stuff in. And then the next guy gets to go. Now, that hasn't been possible until recently with distributed version control and things like Git, and to a lesser extent Mercurial, but Git has won, so Git's the only version control you need to know about for the rest of your life, I think.
Oh, not really.
We'll revisit that in another 5 years.
Not true. No, we have teams that cannot use Git. It's not scalable.
Well, back in the pre-Git days, I faced Project Sun, and we had a rule that when we were working on an ESB, you had to run the tests on 2 out of 3, like locally, you had to run the tests. You had access to a Windows or Linux box locally, and you had access to a Solaris box locally. And you had to pick any 2 of those 3 and run the tests on 2 of those before you committed. Those are pre-commit tests using the non-Git version.
Yeah, so the way I have my build set up with Git right now is we have, are you familiar with Git at all?
No,
I've got a picture going.
I've never seen any environment, anywhere that have used that.
So Git is like a giant Xerox machine for code bases,
Oh, okay.
right? And so I take from the master code base and I make a Xerox of it. And I put a big smiley face on. And I hand it back to the CI server. And the CI server runs its test. It says, that's kind of an ugly smiley face, reject. And then, you know, he puts his puppy on. And the puppy gets checked in, you know. But the idea is that I take my copy, I do whatever I want, I hand it back to the CI server, and he checks it first. He has everything he needs to know to check all my bits in the way that I gave it to him. But he gets to run all the tests on them first and then check in versus check in then test.
Ah,
It's
okay.
You can think of it as task branches, right? Let's say you're doing some work, you check it in on task branch, the tests run, and then, you know, if the test passed, then it merges the task branch onto the master trunk,
Yeah.
main line, whatever you want.
So basically I have a picture here of how this works. Is, you know, first you do a clone of your code in Git, right? You have your local copy repository. Then you create a story branch, just like any branch in your version control. Here's where you do the work. But in Git, you can then upload your story branch up to the CI server before you merge it back into the official repo main branch. And so CI can do your tests here, and if they fail, it never checks it. If they pass, then they check. And sometimes people integrate this also with the manual code reviews, so both the pre-commit functional test and somebody has to review the code before you can check it.
And so for us, for code review, I don't even look at a code review until it has all its tests. Why would I look at it? The tests are failing.
Yeah, right.
And so they have to, the code review has to, if the tests break because of a code change, that's part of the code change, is to go find out why they broke and fix them, eliminate them, or change your code because it's a real bug that, you know, the code was bad.
But the key issue here is that for unit tests, it's pretty standard and easy, right? Unit tests have to pass before the code review. For functional tests, if you're doing something sophisticated, you have to be able to spin up environment under a test just for this small change, right? If you can afford to do it, that's great. And in some cases, you know, you can afford to do it and I upload it. In other cases, it's just too expensive, then you cannot do this for functional testing. You have your functional tests run maybe from several check-ins from several people, you know, in a batch. So it depends on, again, on your context, what you can afford, and you know, what your testing is. All right, good, really good questions. So again, you can just have a kind of a smoke test per module at least to get. Your test should be, your test should be well written because your tests are really not well written. People are going to give up on them, and so again, you're going to sabotage all the investment you made. You have to treat your tests as important code and refactor them and keep them clean and name your variables and all that stuff. So I recommend is that your automation culture is the whole team culture, right? Developers, testers, whatever, work together. You don't have this separation for these kinds of tests. Again, you may have your QA tests that there's value in them, for different kinds of tests, but for these kinds of tests, they have to work together for that. Or in many places, it's really the developers who just own this. The testers just do exploratory. It depends on your cultural choice. Let's see. So yeah, again, your build's working sometimes like a performance test a little bit. Make sure you can rerun your tests, so you have to tweak your test runners a little bit to make sure you eliminate flakiness of the infrastructure that you may have if you go massively parallel, so you have to account for that. And that's it. And you're ready for exploratory testing, which is what the stubborn most came out. And everyone should do exploratory testing. I think it's great. All right. That's all I have. Thanks a lot.
Thank you.